If you're online, it indicates that you're online. Good evening, guys. If you're active, please indicate that you're active. Active indicates that you are active. Good evening, everyone. Please, if you're active, indicate that you're active. We're about to start now. If you're active, indicate that you're active. Please indicate. Once you join, just click on the like button. Once you join, just click on the like button. Once you join, just click on the like button. Indicates that you're active if you're active. If you're active, indicates that you are active. If you're active, indicates in the comment section that you are active. Please indicate. All right, so we're going to start while we wait for others to join. We're going to start this class, then we'll wait for others to join. This is the continuation of yesterday's class on Mathematics 102 under a topic called Turning Point of a Curve, right? And yesterday we were able to solve some problems in this topic. And we started by saying that differentiation is not just all about finding the y, the x, that we have some applications of differentiation. And one of them is the turning point of a curve. Then we say we have two different types of turning points in the curve. We have two different turning points in the curve. We mentioned that we have the maximum turning point and we have the minimum turning point, right? Then we define what maximum is and also define what minimum is. Maximum means the highest point, okay, in the curve, while minimum means the lowest point in a curve. And we also talked about the different types of curve we can have when we have a function. We have the linear curve, we have the quadratic curve, we have the cubic curve. And I gave an illustration that if we have a curve like this is a quadratic curve that opens downward, right? We can also have a curve of this kind. This is also a quadratic curve that opens upward. And we'll say that for a curve of this kind, the general form is simply minus as squared plus bs plus c, where a is less than 0, right? Where a is less than 0. Then for a curve like this, we say the general form is as squared plus bs plus c, where a is greater than 0. All right. So we said for this curve, we have the highest point here is called the maximum point. The lowest point is called the minimum point. Okay. Both the maximum and the minimum point, they are called what? The turning point of a curve, right? And we'll say that at the turning point of a curve, of every curve, that the y, the x is equal to 0. And we'll say we have two conditions to determine the turning point of a curve. We have the first condition, which is called the necessary condition. The necessary condition. Number two, we have the sufficient condition. The sufficient condition. And we say that when we talk about necessary condition, we are saying that at every turning point of a curve, that the y, the x must be equal to 0. Necessary means this is the first condition we must have to test before proceeding to classify a curve into either maximum or minimum turning points or a point of inflection, right? Okay, then we say for the sufficient condition, we say the second derivative of a function must either be greater than 0 or be less than 0 or be equals to 0. So under sufficient condition, we say that the second derivative, the 2y over the s squared, if it's greater than 0, this simply means that we have a minimum turning point. Minimum turning point. Then if the second derivative, the 2y over the s squared is less than 0, we have the maximum turning point. Please don't forget that whenever we say that the second derivative is greater than 0, that talks about positive, right? Positive. Numbers greater than 0 are positive number. While numbers less than 0 are what? Negative what? Negative number. Please don't forget. Then we say that there's a third condition that gives us a stationary point called the point of inflection. That this third condition here, the 2y, when the 2y over the s squared is equals to 0, we have a point called the point of inflection. The point of inflection. Point of inflection is not actually a turning point. A point of inflection is a point in a curve where the curve changes its concavity, or where the curve changes its curvature, all right? Or where the concavity of the curve changes. For example, if I have a curve like this is maximum going to minimum, right? Here we have the maximum point here. The point at which this curve changes its curvature from increasing to decreasing is called the point of inflection. This is called point of what? Inflection. Here we have the maximum points. Here we have the minimum points. So along this, we can also have a point called point of inflection. Okay. And I say that is a point where the concavity of the curve changes from either maximum to minimum, or from minimum to what? To maximum. All right. Like we just saw, the point where it changes to minimum, okay, it's called the point of inflection. So I have maximum, I have pi, I have minimum. Now, in what kind of curve can we actually have point of inflection? Point of inflection is only obtained in a cubic function. Every cubic function has a general form of as cubed plus bs squared plus cs plus d. When you plot a graph of this function, the graph of this function is always in this form, x shape. Okay, so every cubic function always have what we call the maximum, the minimum, and the point of what? Inflection. Are you there? Okay, these are the characteristics of what? Of a cubic what? Function. But quadratic function only have either maximum or what? Or minimum. And I've explained when we obtain maximum and when we obtain what? Minimum. And we say that for us to obtain a maximum function, we say that the general form must have to be, okay, minus as squared plus bs plus c, where we are saying that a must be less than what? 0, right? Okay, when you plot a graph of this kind, we're going to obtain a maximum point, right? But if you plot a graph of this kind, as squared plus bs plus what? Plus c, where a is greater than 0, we're going to obtain a graph of this kind having a minimum what? Points, right? Having a minimum points. Okay, so please take note. But whenever you plot a graph of this kind, as cubed plus bs squared plus cx plus d, the graph of this kind must be in this form, must have to be in this form, where we have the maximum, the minimum, and the point of what? Inflection. All of this we discussed yesterday. If today is your first time rather, in joining us in this class, please ensure you go through the previous class. Okay, the previous class, yesterday's class, is still in our YouTube channel. All right, so let's move on. Now, I want us to take note that yesterday we talked about the two conditions, right? We mentioned the first condition called the necessary condition, that at the turning point of every curve, that the y dx must be equals to what? 0. This is the first condition. Please don't forget. Number 2 is that it's called the necessary, is the sufficient condition. This is called the necessary condition. Then number 2, we have the sufficient condition that says that the 2y over dx squared, okay? When it's greater than what? 0, we say we have here as minimum, right? We have here as minimum turning point, and greater than 0 simply means this is what? Positive. Please take note. All numbers greater than 0 are positive what? Numbers. Don't forget. The second part we also consider under this is that whenever the 2y over what? The x squared is less than what? 0, we say we're going to obtain a maximum turning point, right? Turning point. And don't forget that numbers less than 0 must be what? Negative. Okay. Then the third one is called, if we have the 2y over the x squared equals to a 0, we're going to have here as the point of what? Inflection. The point of inflection. And I'll be showing us how to determine the point of inflection. Today's class, our emphasis will be more on how to find point of inflection of a curve. Point of inflection of a curve. And I will be solving some problems, all right? Please, if you are active, if you are online, indicate that you're online. Indicate that you're online. And once you join us, please ensure you click on the like button. Please click on the like button. Please click on the like button. Please click on the like button. Okay. Please don't forget the steps we mentioned yesterday. The steps we mentioned yesterday. All right, so let's proceed. Don't forget the steps we mentioned yesterday. Sorry for the little break. We mentioned some steps using finding turning point of a curve. The first, we said we have to set the y dx, right, to be equals to 0. Under the, we call this the necessary condition, right? Necessary what? Condition. Number 2 is that when we set this equals to 0, we have to find the value of x, right? Value of x. Don't forget. Okay. Then number 3, we have to find the second derivative, the 2y dx squared. When we find this, then we substitute the value of x we got. We have to test for this, right? We test for this by putting the value of x we got in the second steps into our d2y, right? And we say that after putting the value of x into the 2y, if the 2y over the s squared, if the 2y over the s squared is greater than 0, you know this is minimum turning point. If the 2y over the s squared is less than 0, this is called the maximum turning point. Don't forget, these are the steps we mentioned. Now, I want us to look at this question before we go into the point of inflection. Question says that from the past question, I got the question from the past question I want us to look at. Question says that we should analyze the turning points of this function. The turning point, analyze the turning point of this function, and we are given that y is equals to 2x cubed minus 9x squared plus 12x minus 4. We should analyze this, the turning point of this function. Now, I want us to recall that the first step says at every turning point of a curve, the y dx must be equal to 0. That is called the necessary condition. It means I have to find the y dx and equate the result to 0. So we say that recall at every turning point of a curve, the y dx must be set as 0. All right? So that means that we have to differentiate this. By the time we differentiate this, what we have here, 3 times 2 will give us 6x. We have 6x squared minus 9 times 2, or 2 times 9 will give us 18x plus 12. This must be equals to 0. This must be equals to 0. Now, the next thing we have to do is to factorize this, all right? But if you look at this time, we can divide through by 3. 3 can divide this here. We're going to have here as 2x squared. Here we have 18 divided by 3 will give us 6 minus 6x. Divide 12 by 3, we have 4. All of this is equals to what? 0. You know, when we substitute this, when we differentiate and equate this to 0, what we have to do is to find the value of x, right? And this gives us a quadratic function. So what we do, let's factorize and see what will be the result of this. Okay. We can also divide through again. We can divide through by 2. By 2, that will actually give us, okay, let's go. This will give us what here? 2 here will give us, here we have x squared. 2 here will give us what? We have here as minus 3x. Here we have plus what? Plus 2, all equals to what? 0. Okay, this is the simplified form. Let's factorize this and see what will be the result. And how do we factorize? Multiply the first term by the last term. Multiply the first term by the last term. S squared times 2 will give us 2s squared, right? Okay, 2s squared. All right. What we're going to look for 2 numbers, right? That once we multiply them, the result will be 2s squared. But once we add or subtract, the result will be minus 3x. What are the 2 numbers? That once we multiply, the result will be 2s squared. And once we add or subtract, the result will be minus 3. That should give us minus 2x and minus x. Let's verify this. Minus 2x times minus x is 2s squared, right? Minus 2s minus s is what? Minus 3s. So I can replace these 2 numbers with what? Minus 3x. And that will give us what here? We have s squared minus 2x minus x plus 2, all equals to 0. Between these 2 terms, what is common is x. So we have here as x minus 2. Between these 2 terms, what is common is minus 1. Here we have here as x minus 2. All equals to 0. That means here becomes x minus 1 and x minus 2, all equals to 0. So we can then find the value of our x. Okay. We can find the value of x. And that will give us here. Our x becomes x is equals to 1 or x is equals to 2, right? Okay, among these 2 values of x, one of them must have to be a minimum value of x and the other must be a maximum value of x. So the next thing we need to do is to find the coordinates of the function at s equals to what? 1 and also at x equals to what? to 2. So what we have to do here, we have to say put s equals to 1 in the equation or in the function. The function here says y equals to, let's just replace our x as 1 here. That will give us y equals to 2, 1 to the power of 3 minus 9 times 1 to the power of 2 plus what? Plus 12 times 1 minus what? 4. This will give us y equals to 2. 1 to the power of 3 is 1. 1 times 2 is 2 minus 9, right? 1 square is still 1 times this. Then we have plus 12 minus 4, right? So let's evaluate further. We have 2 minus 9, right? 2 minus 9 plus 12 minus 4. Here we have 1. Our y is equals to 1. Therefore, the coordinates, our first coordinate is when s is 2, y is 1. Also, we have to put x, right, as 2 in the function. To find the second coordinate. Let's put our x as 2. When we put x as 2, that will give us what here? Y equals to 2 times 2 to the power of 3 minus 9, 2 to the power of 2 plus 12 times 2 minus 4. Here we have y becomes 2 times 8 minus 9 times 4 plus 24 minus 4. So let's evaluate further. Okay. 9 times 4 is about 36. Here we have minus 36 plus 24 minus 4. Okay, the result of our y becomes 0. By the time we add up all of this, we're going to have 0. Let's do that again. 2 times 8 is 16 minus, okay, 9 times 4 minus 20 plus 24 minus 4. Our answer is 0. So that means the coordinates here, our coordinate becomes when s is 2. When s is 2, y is 0. Sorry, this other one is when s is 1, right? Sorry. When s is 1, y is 1. This is 1, comma what? 1. All right? Okay. Now, the next is that, so each of these now, coordinates here, will either represent minimum or maximum, right? So what we do now is to apply the sufficient condition. Sufficient condition. So recall that our dy dx is equals to 6s squared minus 18s plus 2, right? So what we do is to differentiate this to find the second derivative. The 2y over the s squared will give us about 12x minus 18. Okay, so we have two values of x. The first value of x is 1, right? So we'll say when x equals to 1, the 2y over the s squared will then be what? 12 times 1 minus 18. Okay, and that will give us about minus 6. Minus 6 here is less than what? 0. Don't forget. Minus 6 is less than 0. That means our d2y over the s squared is actually less than what? 0. Okay. And that means a maximum turning point, right? Maximum turning what? Point. Okay. Since the value of our second derivative is less than 0, it means that we have a maximum turning point at 1, 1. Okay. This simply implies that, therefore, there is a maximum turning point, maximum turning point at 1, 1. At 1, 1. That is what it means. Okay. Now, the next is to verify this. Let's verify when S is what? Is 2. Let's verify when S is 2. When S is 2, when X is equals to 2, that will give us our d2y over dx squared to be equals to 12 times 2 minus 18. This will give us about 24 minus 18. This will give us about plus 6, right? About plus 6. Okay. So 24 minus 18 is plus 6. And plus 6 is greater than what? 0. So we can say that since the 2y over what? The s square is greater than 0, we have a minimum turning what? Points. Minimum turning points. Therefore, minimum turning points occur. Therefore, our minimum turning points occur at 2, 0. At 2, 0. Please take note of this. I just want us to have a recall on what we discussed yesterday before we proceed. Before we proceed into point of inflection. All right. Now I want us to look at how we can sketch this curve. How do we sketch this curve? How do we sketch this curve? Please take note of our points. We agree that minimum occurred at 2, 0, while maximum occur at 1, 1. 1, right? Now let's see, let's look at the curve sketching. Let's look at the curve sketching. Okay, originally we are told that y is equals to 2x to the power of 3 minus 9x squared plus 12x minus 4. Now what we have to do here is to find the roots of this function. You know, in curve sketching, since we have both minimum and maximum, and the highest power is 3, you know, we say that the nature of this graph will look like this. Exactly. Will look like this. If the highest power is 2, it means we can only have either this kind of curve or this kind of wall curve, right? So let's see how we can sketch this curve to look like the function itself. And this curve, we have to look exactly like this. So let's see how we can sketch this curve. Now look at this now. What we have to do is to find the roots of the equation. All right. If I'm to sketch a quadratic curve, let's say I'm to sketch this curve, s squared plus 5x plus, let's say plus 6, s squared plus 5s plus 6. What do we do first is to find the root of this equation. Exactly. So find the root of this equation. And to find the root here is what? Will give us s squared plus 2x plus 3s, right? Plus what? 6. I can factorize this rather to find the root. 2s plus 3s is 5x. 2s times 3s is what? 6s squared. Exactly. So between these two terms, what is common is x. Here we have x plus what? 2. Between these two terms, what is common is 2. Is 3 rather. We have x plus what? 2. Exactly. Let's equate this to be 0 equals to 0 equals to 0. So here we have x plus 3 and x plus 2 all equals to 0. That means our x equals to minus 3 or x equals to what? Minus 2. What does this mean? It simply means that if I'm to sketch this curve, you know, if I have a Cartesian diagram, this is the origin, right? The 0 points. Every numbers here are what? Positive. Is that clear? They are positive. While numbers here are what? Negative. Minus 1. Here we have minus 2. We have minus 3. We have what here? Minus 4. Is that clear? If I'm to sketch this curve, it simply means since the value of our a here is positive, since a is greater than 0. All right. So that means that this curve we open upward. The curve will open upward in this pattern, right? This is the kind of this curve here. Our a is always greater than 0. But when this curve opens downward this way, it means that a is less than 0. That means our a is what? Negative. So knowing that the value of our coefficient of s squared is positive, so that means the curve will have to open upward. And for that to happen, it must have to cause 2 x equals to minus 3 and what? Minus 2 in this pattern. It must have to cause 2 this. Minus 3 and what? Minus 2. The curve must have to come this way. All right? Must have to come this way. Okay. But before then, I have to find the minimum turning point by taking note of the necessary condition and the sufficient word condition. All right. I'm just showing us a rough sketch. What I will have done first is to find this point, right? By differentiating this. Is that clear? Then find the value of x and the value of y. Okay, then if I'm to do that, okay, let's see. Knowing that the root is what? The root of this function is simply x equals to what? Minus 3 and what? X equals to what? Minus 2. Let's see. Let's differentiate this first to get the coordinates of this point. Let's differentiate. That will give us the y dx, right? Equals to what here? We have 2s plus what? Plus 5. And the rule say we have to set this to be equals to what? 0. Is that clear? That means my 2x is equals to what? Minus 5. X is equals to minus 5 over 2. This is about 2.5. Is that clear? 2.5. What do you notice here? The value of x is just somewhere here. Minus 2.5 is just sitting close to here. But let's see. Let's find the value of our y. This is our y, right? Let's find the coordinates of this point by putting this value into y. That will give us y equals to what? Minus 5 over 2 all squared plus 5 times 5 minus 5 over 2 plus 6. Okay. This will give us about y equals to 25 over 4 minus 25 over 2 plus 6. Let's see the LCM between these. Our LCM is 2. Okay, so it's 4 rather. LCM is 4. Okay, 4 into 4 is 1. There we have 25 minus 4 into 2 is 2. 2 times this go minus 50. Okay, 4 into 1 is 4. 4 times 6 is 24. So plus 24. Let's see. Let's add up this. 25 minus 50 plus 24. Okay, that will give us minus 1. Minus 1 over what? 4. So that means our y coordinate is minus 1 over 4. All right? So that means the coordinates of this curve, the coordinates of the minimum points is meant to be when x is minus 5 over what? 2, comma, when y is what? Minus 1 over what? 4. When you look at this very well, the s value is actually correct. Halfway, here we have here as minus 5 over 2. Minus 5 over 2 is about minus 2.5. Minus halfway will give us minus 2.5. Okay, then the value of our y is negative 1 over 4, which is actually somewhere. That means it should be somewhere close this way. Somewhere close this way. Don't mind my curve. Somewhere close this way. Okay, that means the y value here should be equals to minus 1 over 4. While the s value here should be equals to what? 2.5. So this coordinate here is actually minus 5 over 2, comma, minus 1 over 4. Okay, this is just how to sketch this curve. But let's see. What actually led us into this is that, okay, what actually led us into this is that we want to see how we can sketch the curve of the original function we are dealing with that gave us this minimum and the maximum value, right? And we are told that the value of y is equals to 2s cubed minus 9s squared plus 12x plus minus 4, rather. Minus 4. All right? So let's see how we can sketch the curve for this function. Before we can sketch the curve for this function, we have to find the root of this function, like we did in the other function. When we find the root, right? We have to find the root of this function. There's a theorem called the factor theorem. The factor theorem. If you look at this, there's practically no way I can factorize this because each of these terms have different coefficients, and there's no like terms or no like factors between these two. We don't have any like terms among them. Although I can factorize my x, right? If I'm to factorize x, y equals to, let's say x, here we have here as 2s squared minus 9x plus 12. This cannot work this way. So I have to apply what we call the factor theorem. The factor theorem. When you factorize this, by factorizing, the result will give us, let me bring it out so I can explain. Will give us 2s minus 1. Will give us x minus 2 and x minus 2. This will be the factors. All equals to what? 0. When we evaluate this will be the factor. I will show us how to get this. Now, in the factor theorem, it's called trial and error. I have to try some factors. All right. Look at this last term here. I have minus 4. Okay. What are the factors of 4? The factors of 4 are actually plus or minus 1, plus or minus 2, plus or minus 4 itself, right? So I'm going to try plus 1 and minus 1, meaning I'll put plus 1 into this function. If at the end of the day we have 0, it means that plus 1 is a factor of this function. Are you there? If at the end the result is not equal to 0, it means plus 1 is not a factor. Although if you look at this very well, when you put your value of plus 1 or minus 1, you will end up not having equals to 0. Let's try this out and see. Put x equals to what? 1. Let's check. Y is equals to 2 times 1 to the power of 3 minus 9, 1 to the power of 2 plus 12 1 plus what? Minus what? Minus 4. Let's see. Y equals to what? Here where we have 2 minus 9 plus 12 minus 4, right? 2 minus 9 is minus 7. Minus 7 plus 12 minus 4 we have here as 1. Since the result is not equals to 0, it means that x equals to 1 is not a factor. If I'm to try minus 1, let's try minus 1 and see. Let's say put x equals to minus 1. Why are we trying plus or minus 1? Because for this last number here, one of the factors are what? Plus or minus 1. Second is what? 2. Third is what? 3, 4. Are you seeing that I did not include 3 here? So if you have to try any number, always look out for the factors of the constants given in the expression, okay? Now we have seen that plus 1 is not a factor. Let's try minus 1. That will give us y equals to 2 times minus 1 to the power of 3 minus 9 times minus 1 to the power of 2 plus 12 times minus 1 to the, okay, minus 1 minus 4. This will give us minus 2. Minus 1 to the power of 3 is minus 1 times 2 minus 2. Minus 1 square is 1. 1 times minus 9 is minus 9, right? Plus, sorry, minus 12, right? Minus 12 minus 4. Definitely this will not be equals to what? 0. Are we there? So let's try and see. Let's try and see. Please take note. What we are doing here is want to sketch. Before we can sketch the curve for this function, we have to find the root of this function. So we have seen this. This is not a factor. Let's try. Let's say put x equals to 2. That will give us y equals to 2 times 2 to the power of 3 minus 9 times 2 to the power of 2 plus 12 times 2 minus 4, right? So y is equals to 2 times 8 minus 9 times 4 plus 12 times 2 minus 4. Here we have 2 times 8 is y equals to 16 minus 9 times 4 is minus 36 plus 24 minus 4. So here we have 16 minus 36 plus 24, all right, minus 4. This is equals to 0. Now, what do you notice here? When we put the value of x equals to 2, we have 0. Are you there? That implies that x equals to 2 is a factor. So if x equals to 2 is a factor, it means I will divide this function with what? With x minus 2. How do we get x minus 2? When you take this 2 to the other side, if I'm saying that x is equals to 2 is a factor, that means when you bring this in this other side becomes x minus 2. So to get other factors, don't forget that the highest power is 3. It means we're going to get 3 possible what? Values of x. One of them is already x equals to what? 2. Why do we say is x equal to 2? Because after putting this into this, we have what? 0. So what we do next is to find other factor by dividing the polynomial given with the first factor, which is x minus 2. Are we there? But what if we put x equals to minus 2 and we got 0? It means I will not divide by what? X plus 2. Meaning if I'm to use x equals to minus 2, when you bring this to this other side becomes what? S plus 2. So I will divide the polynomial with what? S plus 2. So since I've already tested and we got that x equals to 2 is a factor, okay? So what do we do? I will divide using long what? Division. Now watch. Okay, please take note. So we divide since x minus 2 is a factor. So we divide using long division. And here will give us, we have x minus 2 Here we have 2x cubed minus 9x squared plus 12x minus 4. Let's go and see. I'll divide 2x cubed by x. We have divide 2x cubed by x. We have 2x squared. Divide this with this. We have this. The rule here is that after dividing this with this, and we have this, multiply this value by x. That will give us what? 2x cubed. Multiply 2x squared again by minus 2. That will give us minus 4x. Minus 4x squared. Right? I'll repeat again. Divide this with this. We have this. Multiply 2x squared by x. We have 2x cubed. Multiply 2x squared by minus 2. We have minus 4x squared. So this can go with this. Right? I will subtract 2x cubed minus 2x cubed will disappear. I will subtract all of this with this here. So that's why I have to put my bracket here. So when you subtract this, this will cancel out. So let's subtract and see. Minus 9x squared minus 4x squared. Minus 9x squared minus 4x squared will give us minus 5x squared, right? Minus 9x squared minus 4x squared will give us minus 5x squared, all right? Then minus 12x minus nothing is minus 12x. Minus 4 minus nothing is minus 4. Or just bring down this. Since there's no other terms here to subtract them with, just bring them down, all right? Now, look at this here. The degree here is 2. The degree here is 1. It means I can further divide. So I will divide minus 5x squared by x. That will give us minus 5x. So multiply 5x by x. That will give us minus 5x squared. The same thing we did here, I will repeat it again. So I divided this with this. That gave me this. Multiply minus 5x squared by x. We have minus 5x squared. Multiply minus 5x by minus 2. We have plus 10x. So what do we do here? We subtract again. So minus 5x squared minus 5x squared, we cancel that as 0. Minus 12x minus 10x give us minus 22x. Right? Okay. Then here, I'll bring down what again? Minus 4. The degree here and the degree here, they are the same. I can further divide. So I will divide minus 22x by x. That will give us about minus 22. So minus 22 times x will give us minus 22x. Minus 22 times minus 2 will give us plus. Okay, I think there's a mistake somewhere. Let's verify again and see. Here we have this. When we divide this with this, we have this. This times this will give us this, right? Then this. Okay, divided this. I'm coming, excuse me. Minus 22 divided by times this give us this. Okay. Okay. Minus 2x squared. This will give us this. This times this give us this. This times this give us this. Right? Okay. Then this cancelled. This minus this 5x squared. This came down. This came down. Divide this with this. We have minus 5x. This times this give us minus 5x. This times this give us minus 10x. Okay. All right. So here we have, okay. Here we have this came down. This divide this. We have this. This time this is this. This time this will give us minus this times this will give us plus 44, right? Plus 44. Let's see what we're going to generate here. By the time we subtract this, this will give us 4 minus 44. Okay, there's a mistake somewhere. We're not meant to have a remainder. Sorry. Let me verify the function. Plus 12x, okay. We're not supposed to have a remainder. Please pardon me, yeah. Let's go again. Let's take it one after the other. Okay, let's take this again. We have x minus 2. Here we have 2s cubed minus 9s squared plus 12x minus 4. All right, this is the function, right? Let's divide this with this. We have 2s squared. 2s squared times x is 2s cubed. 2s squared times minus 2 is minus 4s squared. So we subtract, right? This will go with this. Minus 9s squared minus minus. Okay? That will give us minus 5s squared. Minus 9s squared plus 4s squared is minus 5s squared. So this will come down as plus 12x, then minus 4. I will divide this again. 5 minus 5s squared divided by this will give me minus 5x. All right? Minus 5s times x will give us minus 5s squared. Minus 5s times minus 2 will give us minus 10x. All right? Okay, what do we do again? We further subtract again. This will cancel out, right? So we have 12x minus minus. Okay, so we have 12x plus 12x plus minus times minus is plus, Abby. So plus 10x, 22x. Okay, so this should be 22x. 22x. Then we have minus what here? 4. Okay, so minus 4, all right? I will divide this again with this. That will give us plus 22. Plus 22, right? Plus 22. Okay. I think this function itself is not correct. The function itself is not correct. Oh, right. All right, so let's finish up this. Sorry, there was a little issue with lights, so I have to just fix the gem. All right, so this is a live class, so anything can happen. Okay, I think I've seen where the error is. When we multiply minus 5x times minus 2, it's meant to be plus, not minus 10s. So let's subtract again and see. This subtract, right? We have 0. 5s squared minus 5s squared minus 5s squared is 0, right? This is already off. So 12x minus 10x is 2x. So we bring down what? Minus 4, all right? So I will divide this again, divide 2x by x. That will give us what here? That will give us plus 2, not 22. So 2 times 2s will give us 2x. 2 times minus 2 will give us minus 4. So when we subtract further, here will give us 0, 0, right? 0, 0. 2s minus 2s is 0. Minus 4 minus 4 minus 4 is also 0. All right. So to find other factors, I have to factorize this expression. To find other factors, I have to factorize this expression. Let's see. Let's see what the result becomes. Okay. This multiply this first term by the last term, that will give us 4s squared, right? 4s squared. then I will think of two numbers that once we multiply them, the result will be 4x squared. Then when we add or subtract, the result will be minus 5. That should be minus 4x minus x, right? Let's check this out. Minus 4x times minus s is 4x squared. Minus 4x minus s is minus 5x. So I will replace these two numbers, right? With this, that will give us 2x squared minus 4x minus x, then plus 2. Between these two terms, 2s is common, right? That will give us x minus, okay, minus 2, right? Between these two terms, minus 1 is common. We have x minus 2. This is equals to 0, equals to 0. So that means here we have 2x minus 1 and x minus 2 all equals to 0. So you can see that the other factors is also x minus 2. The first factor we got is x equals to 2. So from here, it means that 2x minus 1 equals to 0, or x minus 2 equals to 0. So here we have here as 2x equals to 1, or x equals to 2. That means our x is equals to 1 over 2, or x is equals to what? Minus 2. So the values of x that defines this function are what? 2x minus 1, x minus 2, and that first factor, which is also what? X minus 2. So the values of x are, the first value of x is 1 over 2, followed by what? X equals to what? 2, twice. This actually occurred twice, Abi. The first one is s equals to 2. Also, we also generated what here? S equals to what? To 2. S equals to 2. Are we there? Now, let's see how we can sketch this curve. And let's see how we can sketch this curve. Knowing that we have defined the values of x, let's sketch this curve and see. In the curve, let me bring up my Cartesian diagram. The first thing we need to do is to bring out the minimum point and the maximum points. The minimum point is when x is 2, y is 0. When s is 2, let's say, let me use just a stroke to represent 1 unit. If I have here as 1 and here is 2, I have here as 3, I have here as 4, I have here as 5, I have here as 6, I have here as 7, I have here as 8. Okay? All right, so here will be 0, right? Here will be minus 1, minus 2, minus 3, minus 4, and minus 5. All right? Okay, here we have our y, and here we have our x. So what do we do here? Let's bring out the minimum point. When x is 2, y is 0. The point is here, right? When s is 2, y is 0 is here. Let me put it in brackets, 2, comma, 0. When s is 2, y is 0 is here. When s is 1, y is also 1. Let's indicate 1 here, indicate 2, indicate 3, indicate 4, indicate 5, and 6. So the point at which they meet is somewhere here, right? It's somewhere here. So the maximum is somewhere here. The minimum is somewhere here, okay? So what do we do now? Let's space this. I think the spacing is too small. Let's space them. I'm sorry, let's just space. Let's put here as 1, here as 2, here as 3. Let's put here as 1, here as 2, and here as 3. So let's bring out our points again. Our point, the first point we have is 2, 0. When s is 2, this is point here, right? The second point, this is the minimum point, 2, 0. The second point is 1, 1, which is somewhere here, right? This is 1, what? 1, 1, 1. All right. This is the maximum point. Okay. So the next is to indicate our root of equation. We have two root of equation. We have half and s equals to 2. x equal to 2 appears twice. So I will just take it as 1. So the first we have here is what? Is half. Half, 1 over 2 should be midway, right? Between 1 and 2. Somewhere here we have 1 over 2. Okay. So the next is that our value of x actually falls in here. So that means my curve, 1, 1 is the maximum. So that should be of this kind, the maximum. It means that this curve will come this way, pass through 1 over 2, and curve back in this pattern. Okay? It will come this way from the maximum, pass through the roots 1 over 2, and curve back and enters this. So at this point here, we have, okay, I think there's a mistake here. Let's check. 2 comma minimum. I'm sorry. Our minimum is 2 comma. Okay. Let me take it this way. This curve will be, okay, we are correct. This curve will come this way. And we have 1 over 2 here, right? To come this way, then come this way, and it's meant to give us a curve here. The curve is meant to be in this kind, something of this kind, something of this kind. The curve is meant to come this way. Here we have the maximum, right? The maximum is 1, 1. Then the minimum should be about 2, 0 at this point. Minimum is 2, 0. But this is the nature of the curve, all right? Okay, the main thing I want us to look at is point of inflection. Point of inflection. Point of inflection. Please, if you're active, indicate that you're active. Okay. Okay, I want to check something. I think this curve, there's a mistake somewhere. Let's check this again. The right way of putting this curve. Let's check this again. We have 1, right? We have 2. We have 3. We have 1. We have 2. All right? So let's see this. Our minimum point is 2, 0, which is here, right? 2, 0. Okay. Then our maximum point is 1, 1, which is somewhere here, right? We have 1, 1. All right? Okay. The value of x, 1 over 2, is about 0.5, right? Sorry. This is not 1 point. I was taking this as 1.5. 0.5 should be somewhere here. Thank you. 1 over 2 should be somewhere here. Halfway between 0 point and 1 is 1 over 2. So let's see what will be the result of this. Awesome. So that means this curve will come this way, generate the maximum, right? Yeah, we have the maximum here. Okay, then it comes this way and this way, just like that. So we have the maximum point here, we have the minimum point here, then we can extend the graph upward. All right, so please take note of this. Sorry, the first notation, putting the value of 1 over 2 here is very wrong. This should be about 1.5. So 0.5 should be somewhere between 0 and 1. So here we have the point moves from this way, from this region, and curve downward. Then we have this. So here we have our maximum. Maximum is 1, 1. Minimum is 2, 0. Then we have other points. So between the maximum and the minimum, we can determine the point of inflection. The point where the curve changes its curvature is along this region. All right. So that will lead us to the next aspect where we'll be looking at. Okay. Please ensure you save this video. All right. I want to pause for 5 minutes. Then I will return back. I want also have a fresh video on on the point of inflection. Please take note.